it is one of those things where once you're kind of looking at it from the inside out, it makes sense. But when you're on the outside looking at it, sort of, it doesn't. It's kind of
Yeah,
something kind of
and the name doesn't
don't want
help,
to touch.
does it?
And the name does not help. Yeah. Hello and welcome to the Cloud Therapist channel. I'm Richard Simon. Today we are going to be talking about chaos engineering. Any idea what that is? No idea at all? That's okay. Neither did I until I actually read a book about the subject from a certain author. So today we're going to be covering what is chaos engineering, what it isn't, how can you use it in your cloud environment, and who better to tell us all about it than the actual person whose book I read about that particular subject. So let me introduce you to Mikolaj Pawlikowski, and we'll go on and call Mikolaj Miko, as he likes to be called, and that keeps it nice and short for me as well. Yes, hello, Miko. How are you doing? How's things going?
Doing great. Thanks for having me, Richard.
Absolute pleasure. Chaos engineering is a kind of an area that I've been sort of interested in and fascinated about, and certainly reading your book, and we're going to be covering your book in this particular talk. I found that very, very useful and learned absolutely so much about it. It kind of went from the title, just from the title, to actually understanding a little bit more about the technology and some of the various aspects of that. So Mika, let's start with you, maybe just doing a quick intro to yourself, please.
Sure. I'm a software engineering lead at Bloomberg. I run a team that runs managed Kubernetes. And when I'm not, you probably might bump into me at places like SRECon or KubeCon, where we do some open source stuff. There's a couple of projects that we might probably talk about a bit later, like Powerful Silver Gold Pinger. So that's probably the easiest way to reach out to me through one of these projects.
Fabulous. Okay. And why did you kind of decide to sort of get into chaos engineering? What was the sort of the interesting thing for you about that particular subject?
Yeah, I didn't know what I was getting into, did I? So it's actually pretty simple. So the year is 2016, and I landed on a project that was like greenfield, and we needed to decide how to build it. I wanted to build a microservices platform for data scientists. So we did, the research. We found that Kubernetes seemed to be pretty promising, and by a lucky coincidence, there was a conference, one of the first KubeCons, that was just down the road, literally from the office. So we went to that. We saw that community was being, built around it, and we decided that Kubernetes was worth a go. The problem, on the other hand, was that at least at the time there wasn't like this one right way of running Kubernetes. Well, there still really isn't, but at the time you were just with all these new components that you had to build some experience with. And we basically, in order to sleep well at night, we needed to very quickly build confidence in being able to debug Kubernetes when it went wrong and understand all the caveats and weird things that might happen to it. And then to actually build on top of that, the platform, we needed something. So what we ended up doing was basically writing this little script that were either copying the kind of problems that we saw and trying to see that our fixes around it were working, or that upgrades in Kubernetes were fixing that, or some other things later that we were thinking, okay, if this happens, we try to proactively make sure that that doesn't break us. And then later on, it turned out that it's supposed to be called chaos engineering when I discovered that, and the rest is history. So that's kind of really where it came from, just trying to sleep better at night. often joke that it's basically been a sleep aid.
Right. Yeah. So it's kind of more out of necessity. Excellent. So, and why did you actually decide to write a book about it? I appreciate kind of, maybe sort of trying to learn about it or get into it from sort of a work perspective or a kind of experience perspective, but why actually write a book about it?
Yeah, so there are two reasons really for that, and one is very pragmatic. The other is a bit more philosophical. Philosophically, let's start with that. At the time, there wasn't that much practical resources that you could use for that, because there was obviously the little book from the original chaos engineering gang from Netflix that describes the idea, and that's great. But then how do I actually go about implementing that? So my idea was to write a book that would give you enough tools and enough knowledge and enough like practical stuff that you could actually go open that and start implementing things on your own systems. And that obviously meant covering some of the popular things now. So it's very focused on Linux. There's kubernetes and containers, Dockers, and stuff like that. That was really the primary driver. That at the time, there wasn't really anything that would tell you, okay, so you read that other book, and now either you have to go and pay for some software that does it for you, or you could learn how to do it, using existing tools. So the latter was the primary target. And the more pragmatic one was that they basically called me at Manning and they were like, hey, yeah, we really like that. And we saw Powerful Seal and, some of your talks. Why don't you write a book about it? And I was like, all right.
Sounds like a good idea. Why not? So just very briefly, what was in terms of the writing of the book, what was kind of the best thing about it? And what was the kind of maybe a difficult thing about writing a book?
Right. So I think the best thing about it was the feeling at the end when I actually finished that. I was like, oh my goodness, that was a year in the making. It's actually happened. It also taught me a lot about formulating my thoughts. It was initially a struggle because Manning has very strong kind of opinions about how ideas need to be presented. So they base it on cognitive science a lot, and they basically have unbreakable rules, like saying you first need to introduce your graphs and then show the graphs so that people remember it better, rather than every other book that I've ever seen that says, oh, look, figure, and let's discuss it afterwards. So stuff like that was initially a little bit well, I had to buy into their little dogma, but I've got to say that after it was done, it basically requires more upfront effort from the author, but it does read much easier. You never have to like go back to the previous page and look at the graph that you're discussing. So that was basically the best and the worst, I think, of the experience. Yeah, I'm not going to talk about the early mornings and late nights. That's kind of, obvious drawbacks, but the feeling when it was done, and I could actually hold a physical copy, because until it's physical and printed, it's all on the internet, so it doesn't exist. So
Absolutely, yeah,
that was good.
Fantastic. Okay, so just before we dive into the kind of the details of the book, I just kind of wanted to maybe just lay out some of the definitions in this space of kind of chaos engineering and so on. So a quick definition of actually what is chaos engineering for you.
Yeah, so you see, we're doing that too now. So it's going to be cognitive dissonance now. We're going to start with the definitions and then talk about them and give examples. If it was a Manning book, we would first give an example and they say, oh, look, you just discovered chaos engineering. But hey, let's do it the old-fashioned way.
Old-fashioned way, exactly.
Chaos engineering is, so basically the definition that I consider canonical is the one that you can find on principlesofchaos.org. And it goes something like this: a discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. And that's a mouthful, but basically that means it's experimenting on X piece of software in order to feel better about it working during difficult conditions. So a lot of people are, kind of, when I talk to them, they compare it to kind of like end-to-end tests. So, obviously you start with your unit tests, you test like a small little subset of your code, right? Then you go higher up and you start testing bigger blocks. You do some kind of integration test. Then probably at some point you get to end, hopefully, when you test the whole system. But that's like a happy path. And basically the chaos engineering, the way I see it, at least, is like the next step after that, where you do end-to-end testing, but during the time that things break. And the things breaking, it can be anything that you reasonably expect your system to be able to handle, or you need it to be able to handle that. So it could be anything from systems going down or networking getting saturated and getting all of a sudden slow, or the evergreen. It can't be DNS. I'm afraid it's DNS. It was DNS kind of
Right.
scenario. So
Okay.
yeah, does that make sense to you?
Cool. Yeah. And in an article, I found an article in Tekorati, I believe that I think somebody kind of talked to you about, and I think you defined it there as you said, the discipline of experimenting on a software system in production in order to build confidence in the system's capability to withstand turbulent and unexpected conditions. I think that was
So
your
there
definition.
you go. We have a little distortion. So the production bit is probably like the biggest point of contention, because
I was just going to ask you, actually, does it have to be in production or?
yeah, and the answer is it doesn't. But a, a lot of the early communications about it were around production, because it's one of those things that you can actually do in production when you've
Mm,
tested all the previous stages and you're so confident that you actually go and test it in production. You can, and in many cases that makes sense. But a lot of the early communications were really focused on the production aspect, because it makes better headlines, right? And
mm,
breaking things in production,
yeah,
and when people are being serious with a straight face saying that in public, all of a sudden it's not a meme. So I think that's one of the biggest confusion points, that in the definition, the way, at least in my version of the definition, you want to increase your capability, confidence in the system's capability of working well in production, but that doesn't necessarily mean that you have to do all of your testing in production. The kind of common sense still applies. The way you wouldn't deploy your code straight to production, it's the same with chaos experiments. You build up
sure.
to that.
Yeah, and I think in this kind of the brave new world of sort of cloud and cloud native, I think sort of embracing sort of the change and kind of failing fast and things like that is all normal. Was kind of in the more sort of traditional sort of environments and monolithic applications. It's the other way around. You're trying to build in resilience, high availability, and so on to actually prevent any failures in testing against that, but not actually deliberately introducing chaos into into the mix, so to speak. Okay, so that's kind of some of the sort of misconceptions, I guess, of how sort of people maybe misunderstand that, and maybe from the title. But I just kind of wanted to turn to asking, why would you want to do chaos engineering? What is kind of the just briefly again mention some of the benefits of kind of doing that.
All right, the sales pitch. Let's do
Yeah.
it. Right. So there's a few different reasons, and they're going to be different priorities for different people. Depends, obviously what you're testing. One of the kind of biggest advantages of doing something like this is when you have a distributed system. And in distributed systems, fun things happen. One of the fun things that happen are what we call the emergent properties. And I really like this kind of thing, because it's really easy to explain. Like, if you think about neurons in your brain right now, right? If you take one of them, it doesn't do much by itself. It doesn't have the property of conscience, doesn't have a property of thinking, doesn't really do much. But when you put them all together in this distributed system, all interconnected, all of a sudden you end up with this emergent property of consciousness, like through magic. Or, same goes for like your heart. You have this cells, and by themselves, they don't do much, but put together in the right order and, in the right shape and form, and all of a sudden they start pumping your blood and doing all kinds of things that let you lift weights. So the same thing happens to different other systems, and in particular to software computer systems, where in this kind of distributed environments, you have these different actors, and you have all these race conditions, and you have all these things where slowness is so much worse than something not working because it's so much more difficult to debug. So when you introduce a little bit of failure or a little bit of slowness or a little bit of something in one of the components, you can accidentally kind of more or less discover some of these properties. And sometimes it can really save your skin. And this is kind of a little bit like, the practice of fuzzing, when you like generate all these random inputs and they're valid inputs, but they might not be what the programmer who wrote that had in mind, and you run it and you run it and you run it and you see what happens. And this is kind of one of the aspects of what you can do with chaos engineering, right? And there's kind of like this spectrum of how deliberate you want to be in this experiment. So on one hand, you can basically start and introduce some randomness, right? And then you don't need to know that much about the system. You kind of hope a little bit that you're going to discover eventually the race conditions and stuff like that. On the other side of the spectrum, it can be super deliberate, and you can be testing and designing experiments for a particular property of the system that you're very interested in because it's important for you. And, all of the experiments are going to kind of fall in between all of this. And then, obviously, if you're talking to like a manager, one of the primary drivers is going to be the $ value. And if you explain to them that we can potentially find bugs that we wouldn't catch otherwise early, and only X% of our users are going to be exposed to that, that's, $2 in their eyes, and that works reasonably well. And another argument that goes very well with people who've ever been on call and ever had a pager is that unlike with every outage, there's like this conspiracy that happens at the worst possible time. It's typically at 4 a.m.
Right. Yeah.
And you have to
It's
wake
always
up.
at 4 a.m.
Have to log in, and it couldn't wait 3 more hours before you get into the office. You have the context switch, the computer has a tiny screen, whatnot. All these things are kind of conspiring for you to not be super efficient at handling that. But if you do the testing and even introduce a failure, and even worst case scenario, something actually goes wrong that you didn't expect with the system, everybody's in the office, right? You're there. You can fix it much quicker than otherwise. And with everything that you actually fix like that, you decrease the probability of that happening when you're not looking. So, if you ever had to like find a laptop or like a computer with internet connection in a hotel on a holiday, that's really some of arguments that really speak to you, right? So, yeah, that's like a quick intro, my top 3 that I would mention.
Okay, excellent. Okay, and just very briefly before we go into kind of a bit more the book itself, Chaos Monkey seems to be sort of a term that's kind of touted around in this space. It's kind of briefly describe what Chaos Monkey is.
Sure. So that's the original chaos engineering thing that came from Netflix. So Netflix famously moved on to AWS, and they basically came up with this idea to see what happens when they take VMs down. just like, hypervisors crash and VMs have to be restarted somewhere else. They decided they had this idea to do it on purpose and see that things work the way that they want. And this eventually materialized in the open source project Chaos Monkey, which basically in its initial form did precisely that. You could configure it to take VMs down at certain times of the day. And this is kind of where all things started. And this is where all the first blog posts were featuring. And the kind of monkey has stuck with us now. So, everybody's trying to come up with their own animal, but monkey is kind of like a sticker animal for chaos engineering.
Thank you for watching this talk. If you enjoyed the content, please comment, share, like, and subscribe. See you next time.